Look around you for a moment. The ground beneath your feet, the air in your lungs, even the atoms inside your body. All of it is made of matter. But here's the mind-bending question. Why does matter exist at all? The universe could have been completely empty. An endless darkness filled with nothing but energy and silence. No stars, no planets, no galaxies, and certainly no life wondering how it all began. Yet somehow, out of the chaos of the early universe, particles appeared. Those particles gathered into atoms, atoms into stars, and stars into the vast cosmic structures we see today. Somewhere along the way, the universe turned energy into matter, and that transformation built everything we know. But here's the real mystery. According to physics, matter and antimatter should have destroyed each other in the first moments after the Big Bang. If that had happened perfectly, the universe today would contain nothing but light. No galaxies, no planets, no you. So what changed the outcome? What tiny cosmic imbalance allowed matter to survive and eventually create the entire universe around us? Tonight, we're going to travel from the smallest particles to the largest galaxies to uncover one of the deepest mysteries in science, the mystery of why anything exists at all. Out in the vastness of space, the universe appears full, crowded with stars, galaxies, and glowing clouds of cosmic dust. Yet a deeper question quietly lingers behind everything we see. Why does any of this exist at all? Why is there matter in the universe instead of nothing but empty space? Imagine standing beneath a perfectly dark night sky, far from city lights. Every star you see is made of matter, tiny particles assembled into blazing spheres of nuclear fire. The planets orbiting them, the asteroids drifting through space, even the atoms inside your own body all belong to the same cosmic family. But here's the strange part. Physics suggests that the universe didn't have to contain matter at all. In principle, it could have remained an empty ocean of energy or even absolute nothingness. Instead, the cosmos somehow produced particles that gathered together and built everything we know. It's a bit like walking into a vast desert and suddenly finding a sprawling city. You can't help but wonder, how did all these structures appear here? What process turned the emptiness of the early universe into the rich cosmic landscape we observe today? To unravel that mystery, we first need to look outward and recognize just how much matter fills the universe around us. Because everywhere astronomers point their telescopes, they find something remarkable waiting in the darkness. When astronomers lift their telescopes toward the night sky, they're not just seeing a handful of stars scattered randomly across space. What they're actually observing is a universe overflowing with matter. Every glowing point, every hazy spiral, every distant smudge of light represents enormous collections of particles gathered together over cosmic time. Take a moment to imagine zooming outward from Earth. First, you'd pass the moon, then the planets, then the icy edge of our solar system. But the journey wouldn't end there. Far beyond lies a vast ocean of stars packed into our home galaxy, the Milky Way. And the Milky Way itself is just one of hundreds of billions of galaxies scattered across the observable universe. Each of those galaxies contains billions, sometimes trillions, of stars. Around many of those stars orbit planets, moons, and swirling disks of dust and gas, all built from the same basic ingredient, matter. Astronomers often describe galaxies as cosmic cities of stars. Some spin gracefully like giant pinwheels, while others stretch into long glowing spirals across the darkness. Inside them, immense clouds of gas collapse under gravity, forming new stars the way raindrops gather inside storm clouds. So wherever scientists look, the same pattern appears again and again, matter assembling itself into structures both small and unimaginably large. But that raises an even deeper question. If the universe is filled with matter, what exactly is this mysterious substance made of at its most fundamental level? Now the perspective shifts dramatically. Instead of looking across galaxies and star systems, the journey dives inward, past planets, past mountains and oceans, down into the invisible architecture of matter itself. What appears solid and permanent at our scale is actually built from unimaginably tiny components. Every rock, tree, and human body is made from atoms. These atoms are so small that billions of them could fit across the width of a single grain of sand. Yet despite their size, they are the fundamental building blocks that construct everything we see in the universe. Inside each atom lives an even stranger world. Electrons swirl around a dense nucleus, almost like tiny planets orbiting a star. And inside that nucleus, particles called protons and neutrons are themselves made of smaller ingredients known as quarks. It's a bit like discovering that a city is made of buildings. The buildings are made of bricks, and the bricks themselves are made of smaller pieces still. As scientists peel back layer after layer, the universe reveals a hidden hierarchy of particles assembling into more complex structures. From these tiny particles emerge atoms, from atoms come molecules, and from molecules arise planets, oceans, stars, and living beings. But how did all these particles gather together in the first place to form entire worlds? To answer that, the journey must expand again, back outward to the scale where planets themselves begin to form. Now the camera of our cosmic journey pulls back again, leaving the microscopic world of particles and atoms behind. Those tiny building blocks don't remain scattered forever. Under the quiet but persistent pull of gravity, they begin to gather, slowly assembling into much larger structures. Picture a vast cloud of gas and dust drifting through space. At first it's thin and diffuse, like fog spread across a valley. But gravity starts pulling the particles inward, drawing them closer together, much like snowflakes clumping into a snowball when rolled across the ground. As the cloud collapses, the center becomes hotter and denser. Material begins to swirl around like water spiraling into a drain. Within this rotating disk of matter, tiny grains collide and stick together, forming larger and larger clumps over millions of years. Eventually, those clumps grow into planet-sized worlds. That's exactly how planets like Earth were born, out of cosmic debris orbiting a young star. The same atoms that once floated silently between the stars eventually became mountains, oceans, and even the air we breathe. In other words, every planet is a story of matter gathering itself into something stable and complex. But scientists still wonder how matter behaved in the earliest moments of the universe, and how they can recreate those extreme conditions here on Earth to study it. Back on Earth, scientists have built machines designed to explore one of the most fundamental mysteries in existence: how matter behaves under extreme conditions. These machines are called particle accelerators, and in many ways, they act like time machines, allowing researchers to glimpse the physics of the early universe. Inside these enormous facilities, particles are accelerated to speeds incredibly close to the speed of light. Guided by powerful magnets, they race around massive circular tunnels before smashing into each other. When these collisions happen, they release bursts of energy similar to those that filled the universe just moments after the Big Bang. Imagine two speeding trains crashing together, except the trains are particles smaller than atoms, and the collision takes place at nearly the speed of light. The energy released in these impacts briefly recreates conditions that existed when the universe was only fractions of a second old. From the debris of these collisions, new particles can appear and vanish in the blink of an eye. By studying these fleeting flashes of matter, scientists learn how the fundamental ingredients of the universe interact, combine, and transform under extreme energy. In a sense, laboratories on Earth are recreating miniature versions of the early cosmos. And what these experiments reveal leads directly to one of the most famous insights in physics: the surprising relationship between energy and matter itself. At the heart of modern physics lies a remarkable realization: matter and energy are not completely separate things. Instead, they are two forms of the same cosmic substance, able to transform into one another under the right conditions. This idea changed how scientists understand the universe itself. MC2. This relationship reveals that even a tiny amount of matter contains an enormous amount of energy. The speed of light, represented by c, is such a large number that when it's squared, the result becomes immense. In simple terms, matter is like energy that has taken on a stable physical form. In extremely energetic environments, the reverse can also happen. Pure energy can transform into particles of matter. It's similar to water vapor cooling and condensing into droplets. Except here, the transformation is between energy and the very particles that build the universe. When powerful bursts of energy appear, such as in particle collisions or in the early universe, they can produce pairs of particles and antiparticles. These pairs briefly pop into existence, like sparks flying from a grinding wheel, before sometimes disappearing again. So matter may have emerged from intense energy during the universe's earliest moments. But once these particles existed, gravity began shaping them into something much larger, structures that would eventually form stars, planets, and entire solar systems. Now the cosmic story moves to our own neighborhood of the galaxy. Long before Earth existed, our region of space was filled with a vast cloud of gas and dust drifting quietly through the Milky Way. This cloud contained the raw material that would eventually become the Sun, the planets, and everything orbiting them. Over time, gravity began pulling the cloud inward. It's similar to how a spinning ice skater pulls their arms in and starts rotating faster. As the cloud collapsed, it began spinning more rapidly, flattening into a wide rotating disk of matter surrounding a brightening center. At the heart of this swirling disk, the Sun ignited, a newborn star fueled by nuclear fusion. Around it, countless grains of dust and ice began colliding and sticking together, slowly forming larger bodies. These growing clumps of matter were the seeds of the planets. Over millions of years, those seeds gathered more material, eventually becoming the worlds we know today: Mercury, Venus, Earth, Mars, and the giant planets farther out. What began as scattered particles in a cloud had now assembled into a full planetary system. And among those planets, one small world developed something extraordinary: conditions that allowed matter to organize itself in an even more complex way. On Earth, matter didn't just form rocks and oceans. It eventually formed life. Here on Earth, matter has taken on some of its most remarkable forms. The rocks beneath our feet, the water flowing through rivers, and the air filling our lungs are all arrangements of the same atoms that once drifted through ancient clouds of cosmic gas. Carbon atoms build the molecules of life. Oxygen atoms combine to form the water that covers our planet. Iron atoms flow through our blood, carrying oxygen through our bodies. Each of these elements has a story that stretches back billions of years into the history of the universe. Long before Earth existed, massive stars lived and died across the galaxy. Inside those stars, nuclear reactions forged many of the elements we rely on today. When the stars eventually exploded as supernovae, they scattered these elements across space like cosmic seeds. Those seeds later became part of new clouds of matter that collapsed to form planets, including our own world. In a very real sense, the atoms inside every living organism were once inside ancient stars shining in distant corners of the galaxy. So the existence of matter doesn't just explain the formation of planets, it explains why life itself is possible. And when scientists look beyond Earth, they begin to see that the same processes shaping our planet are happening across entire galaxies. Now the journey expands once again, leaving the scale of individual planets behind. From far above, entire galaxies appear, vast islands of matter floating in the dark ocean of space. Each one is an enormous system where gravity pulls billions or even trillions of stars into a slow cosmic dance. Our own galaxy, the Milky Way, is one of these immense structures. Its spiral arms stretch across more than 100,000 light-years, filled with glowing stars, drifting clouds of gas, and dark lanes of cosmic dust. Every one of those features is another expression of matter shaping the universe. Within galaxies, matter behaves a bit like weather systems on Earth. Giant clouds of gas swirl and collapse the way hurricanes form in warm oceans. As gravity compresses these clouds, new stars ignite, lighting up the galaxy with bursts of fresh starlight. Around many of these stars, disks of material spin like miniature solar systems in the making. Over time, the same familiar process repeats. Particles clump together, worlds begin to form, and complex chemistry unfolds inside nebulae and planetary environments. So galaxies are not static objects. They are living systems of matter constantly evolving, forming stars, planets, and new cosmic structures. But to truly understand why matter exists throughout the universe, scientists must look even further back, to the earliest moments of cosmic history. To understand why matter exists at all, the story must travel back to the earliest moments of the universe. Nearly 13.8 billion years ago, the cosmos began in an extremely hot, dense state, an event scientists call the Big Bang. In those first fractions of a second, the universe was not filled with stars or galaxies, but with an intense storm of pure energy. Temperatures were so high that particles could not exist in stable forms. Instead, energy continuously transformed into particles and antiparticles, which instantly collided and annihilated each other again. It was like sparks appearing and disappearing inside an unimaginably powerful cosmic fire. Under normal conditions, physics suggests something surprising. Matter and antimatter should have been created in perfectly equal amounts. Each particle of matter would have met its antimatter twin, and both would have vanished in flashes of energy. If that had happened completely, the universe today would be filled with radiation, but no matter at all. But something subtle changed the outcome. For reasons scientists are still trying to understand, the universe produced just a tiny bit more matter than antimatter. The imbalance was incredibly small, roughly one extra particle of matter for every billion particle-antiparticle pairs. When the pairs annihilated each other, that tiny surplus of matter remained. And from that almost unimaginable sliver of leftover particles eventually emerged galaxies, stars, planets, oceans, and living beings. In other words, everything we see today may exist because of a microscopic imbalance in the earliest moments of the universe. The existence of matter transforms the universe from an empty void into a place of astonishing complexity. Instead of endless darkness filled only with energy, the cosmos became a stage where structures could emerge, stars igniting, planets forming, and galaxies slowly weaving themselves across space. Because matter exists, gravity has something to pull together. Clouds of gas can collapse into stars. Stars can forge new elements, and those elements can assemble into planets. Over billions of years, the universe evolves like a grand cosmic story written in atoms and light. On one small planet orbiting an ordinary star, those atoms eventually arranged themselves in a very unusual way. They formed molecules capable of storing information, adapting, and evolving. In time, those molecules became living organisms capable of asking questions about the universe itself. It's a remarkable thought. The same particles created in the earliest moments of cosmic history now exist inside the human mind. The universe didn't just produce stars and galaxies. It produced observers capable of wondering how it all began. And so the question of why matter exists is more than a scientific puzzle. It's a doorway into one of the deepest mysteries imaginable. Why the universe became a place where something, rather than nothing, could exist at all.